Good day, viewers. My name is Odi Godwin Daniel, and I'll be your tutor for today. Today, we'll be looking at converting from order basis to base 10. In our last class, we looked at listing the members of a base, and we state that base 10 is the natural base in which every mathematical operation is carried out. We also state that the highest number you can find in any base is one less than the base itself. For example, if we have base 10, for example, we say that the highest number in base 10 is 1 less than the base, which is 10, and that gives us 9. You might want to check our YouTube page for the last class so that you can get a full understanding of what we are talking about. Today, I'm going to be learning converting from order basis to base 10. In order to convert from order base to base 10, two methods are possible. Method one is by adding the place values of the number. And then method 2 by repeated multiplication. Consider the number 6214. In order to get the place values of this number, the first thing to note is what base is the number on, so which is this number here. Remember, in our last class I stated that if the base is not noted, then the number is in base 10. However, if it's in any other base apart from base 10, the base number must be indicated as a subscript of that number. So we know that 6214 is in base 10. So in order for us to get the place value of this number 6214, the base, which is 10, you raise the base to numbers from 0 and above, but we are raising it backwards such that the last number will be given the base, which is 10 raised to the power of 0. The next number will be 10 raised to the power 1, 2 is 10 raised to the power 2, and this is 10 raised to the power of what? 3. So to get the place value of this number, we multiply each number by its place value, which is what? 6 times 10 raised to the power 3. So the place value of 6 will be 6 times 10 raised to the power 3 is what? 10 times 10 times 10, which is 6 times 1000, and that gives us 6000. The place value of 2 will be 2 times 10 raised to the power of what? 2, which is 2 times 10 raised to the power 2 is 10 times 10, which is 2 times 100, which is what? 200. The place value of 1 is 1 times 10 raised to the power of what? 1, which is 1 times 10 multiplied in one place, and that gives us, of course, 10. And then the place value of 4 is 4 times 10 raised to the power of 0. You know, remember, anything raised to the power of 0 is what? Is 1. So that's 4 times 1, which is what? 4. So these are the place value of each number of this number 6214. Consider the number 3221 base 6, for example. So we want to convert 3221 base 6 to base 10. 3221 base 6 to base 10 using the first and the second method. So method 1 is to find the place value of this number, which is in base 6, add them together, and then that would be the converted number from base 6 to base 10. So first thing first, to get the place value system of this number, the first thing to note is the base in which the number is written. And the base in which 3221 is written is what? 6, which means the last number will be 6 raised to the power of 0, and this is 6 raised to the power of 1, 6 raised to the power of 2, and 6 raised to the power of 3. So each number multiply its corresponding place value, which is 3 times 6 raised to the power of 3. Of course, so we are adding it now. And then we have 2 times 6 raised to the power of 2 plus this 2 times 6 raised to the power of 1 plus 1 times 6 raised to the power of 0. Alright, so this gives us 3 times 6 times 6 times 6 plus 2 times 6 times 6 plus 2 times 6 and of course plus 1 times 1. So if we multiply this gives us 3 times 6 times 6 is 36. 36 times 6 is 216 plus 2 times 36 plus 2 times 6 plus 1 times 1. Okay, 3 times 216 is 648, right? Plus 2 times 36 is 72, plus 2 times 6, 12, plus 1 times 1, 1. 648 plus 72, that gives us 720. 720 plus 12, that gives us 732. 732 plus 1, that gives us 733. Of course, we converted to base 10, so it's not compulsory that the base number be written. Alright, method 2. By repeated multiplication. And by repeated multiplication, what do we do? What do I mean? The first thing is to note what base is the number written on, and that's what base, that's base 6. So if you have base 6, the first number here is 3. You multiply the first number by the base, which is 3 times the base is what? 6, and that gives us 18. Now, plus the next number is what? 2, that gives us 20. 20, then of course your result will be multiplied by the base, which is 6. That is why it is called repeated multiplication. You repeat the multiplication until you get to the last number. So we have 20 times the base, which is what? 6, and that gives us 120. The next number here is what? 2, and that gives us 122. Repeat the multiplication again by the base, which is 6. We have 12, we have 3, we have 7, plus the last number is what? 1, and this gives us 733. Of course, it's in this step. So you can decide to use any of the numbers, any of the method, either by adding the place value system of the number given or by repeated multiplication. You will have the same answer. Alright, let's look at another example. 3D4A base 16. Now, if you look at this, base 16 is higher than base 10, right? Base 10 is our natural base in which every mathematical operation is carried on, which means the highest number in the natural base is 9. 10, 11, 12, 13, 14 in base 9, in base 10 does not really exist as a number. When we get to base 11, for example, base 11, you know, the greatest number you can find in any base is 1 less than the base, which means the greatest number you can find in base 11 is 1 less than the base itself, which is 11, and that is 10. However, by our natural base, which is base 10, the greatest number is 9. So if we begin to list the members of base 11, the primary numbers, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, of course 10. However, our 10 will now be represented with the number A, capital letter A. The same thing if we have base 12. The greatest number you can find in base 12 is 1 less than 12, which is what? 11. So if we list the primary numbers of base 12, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So when you get to 10, instead of writing 10, we have A, which represents 10, and of course 11, B, which represents 11. So the primary numbers in base 12 will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B. Of course, the same thing for base 16. Of course, the greatest number you can find in base 16 is 1 less than 16, which is what? 15. So which means the primary numbers in base 16 are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So when you get to 9, you represent with alphabet. We have A, which is 10. We have B, which is 11. 11, we have C, which is 12, we have D, which is 13, we have E, which is 14, and we have F, which is what? 15. So these are the primary numbers in every of these base higher than base 10. To convert this to base 10 using the two methods we've learned above, right? So this is number 3, this is 13, this is 4, and this is 10. So just the same way. And of course, so the first thing to note is the base. The base this number is written on is given is 16. So the last number, which is A, will be 16 raised to power 0, and this is 16 raised to power 1, this is 16 raised to power 2, and this is 16 raised to power 3. So the base number, the numbers are multiplied by their place value, which is 3 times 16 raised to the power of 3 plus D times 16 raised to the power of 2 plus 4 times 16 raised to the power of 1 plus A times 16 raised to the power of 0. Please, give me a calculator. Let's see that.
This is just one of the videos.
4,096.
How many is it?
2. 4,096.
Why not?
I'm a good.
I think we should just batch create. Like if you have energy.
4,096. Alright, so this is 3 times, of course, 16 raised to the power of to the power of 3 means I'm multiplying 16 in 3 places. That's 16 times 16 times 16 plus D is 13 times 16 times 16 plus 4 times 16 plus A is 10 times 16 raised to the power of 0 is what? 1. And this gives us 3 times 4,000. 16 times 16 is 256. 256 times 16 is 4,096 plus 13 times 16 times 16 is 256 plus 4 times 16 then plus 10 times 1. All right, 3 times 4,096 will give us 12,288, okay, plus 13 times 256 will give us 3,328 plus 4 times 16 is 64 plus 10 times 1 10. 12,288 plus 3,328 plus 64 plus 10 will give us 15,690. Our result is in base 10, so there's no need to indicate base 10 as a subscript. Alright, let's use the second method to convert 3D4A base 16 to base 10. Method 2. Okay. So of course, the first number multiplies the base 3 times 16. That gives us 48. Plus the next number D, which is 13, and this is 61. 61 times 16. That gives us 976. Plus the next number is 4, which is 980 times 16, and that gives us 15,680 plus the last number is A, which is what? 10, and that gives us 15,690. Our result is in base 10, so there's no need to indicate the base. Thank you for joining class today. Hope you enjoyed the class. Please like, share, comment, and subscribe to our channel at Gordon School of Mathematics. I'll see you in the next class. Thank you.